Hello friends, welcome to SY Academy. In this video, we will going to study about asset properties, which is quite common and despite of several advances in the IT technologies, asset property is something which is very basic and asked repeatedly in the interviews, and also you should know about it. So what does asset means? Asset is an acronym which stands for atomicity, consistency, I is for isolation, and D is for durability. Keep on repeating it again and again so that you are able to recall it. And these are the four key properties that ensure the reliability, integrity, and correctness of transactions in a relational database. Please note some words such as relational database, and the second word is transactional. I would like to ask you in the comment section to define transaction. What is transaction for you? Some people also relate transaction with a payment, which is not entirely true. So I would like you to define transaction in the comment section. So first, let's discuss about atomicity. And please note atomicity, the word is coming from atom, right? And if you have studied basic science, I'm repeating basic science, right? Not the advanced physics. In basic science, atom cannot be broken or it is indivisible, right? We studied that. Why I use the word basic science? Because in advanced physics, you can break your atom through nuclear fission and some other methods also. But in basic science, you cannot break it, right? So that's how you can define your atomicity. Atomicity means all or nothing, either full or nothing. So what does it mean is that a transaction is either fully committed or fully rolled back. Rollback means whatever you are doing will not happen and will traverse back. Let me give you one example after in few seconds. So if one part of the transaction fails, the entire operation is undone, right? Let's say there are series of steps that you are doing A, B, C, D, right? Let's say A was successful, B was successful, but C failed, right? Then your B and A will also be returned back or will be failed or they will be undone. This is called as rollback, right? Like this. Even if D is failing, then your C, B, and A will be rollback. So this is like reversing the direction or going in the back direction if something is failing. Let's take one example of also of SQL to explain atomicity in little bit detail. Let's say this is the SQL queries, right? In the first SQL query, you are updating your balance and you are deducting it by 500 bucks or 500 currency or anything. And in the second query, you are increasing the balance, right, by 500. Now, let's say this is debit, this is credit, and this is a part of single flow or single sequence of steps that you want to perform, that you want to deduct first and then you want to add, right? For example, if A is transferring money to B, right? Then you will deduct from A and you will increase the balance of B. So this is what is happening here also. Now let's say if this query is successful and this query fails, then as per atomicity principle of relational databases, first will also be failed. That means it will also roll back. What we are trying to say by this discussion is this complete series of steps, right, are considered as one. So either all, that means both will happen, or none of these will happen. Please note that if there are 10 steps in between, 10, right? You wrote begin, you wrote commit, right? And if you know about your Spring Boot and you know about annotations, then if you have written like annotation like this at transactional, right? At top of your function, then anything under it will be considered as one. So if something is breaking, then previous steps will also fail. So what is written here? If the credit operation fails due to any reason, the debit will also roll back. This is called as atomicity. Let's take one real example of e-commerce. Let's take one scenario that you are placing an order on a laptop for a laptop, step one is reduce item cost in an inventory. Let's say there are 50 laptops, then they will be changed to 49. Then your money will be deducted from the wallet, right? Then invoice will be generated. Now, what Atomicity does, right? If a step two fails due to any reason, right? Then your step one and a step three will also roll back. And this will prevent inventory shrinkage. You can understand the importance of Atomicity from this, right? You are getting a control of all these steps, right? You don't need to worry that, okay, if I'm not able to deduct money from the user account, then I should not be reducing the inventory count, right? This is achieved through atomicity. So atomicity coming back, let's discuss about the second property of acid, which is consistency. It means valid state in and valid state out, right? That's how you can remember it. Atomicity all or none. Consistency is valid state in, valid state out. This ensures that your database remains in a valid state before and after the transaction. It enforces constraints, triggers, and foreign keys, right? Let's take one example. Let's take very simple example, a finance example. If the account balance should never go negative, right? That's how you have put a constraint over your database, right? Let's say this is a constraint, right? That your account balance should never go negative. Then if any transaction is reducing your balance to negative, that transaction will be rejected. What I'm trying to say is, let's say your account balance is $1,000. One transaction reduce the balance to 500. Next transaction is trying to reduce the balance to 700, right? Then this will fail. This will fail because your database or your table or your schema is coming in inconsistent state, right? This is called as consistency, right? Please note that this consistency is little different from the consistency that we study in CAP theorem, right? This consistency means that your database will remains in a valid state, right? What is valid state? Valid state is something which is defined by you. Let's say you are saying that age can never be negative, or it can never be more than 150 years, right? Let's say you have defined this. Then your relational database will ensure that this holds true. Let's take one example of gaming experience. Let's say a player experience should never go negative, right? You must have played several games. Your rank always remain positive, right? It never goes negative, or your experience level never goes negative in the game, right? Let's say if a transaction by mistake is taking your experience level to negative, then your database will reject that query. What this ACID is ensuring, guys, is even if you have written some incorrect logic in your service layer, then your database will make sure that that query is rejected. So your DB will reject the query. You will get one exception in your service layer, and whole flow will be rejected, right? So your system is not going in inconsistent state. Please note, a lot of young engineers are confused in this. Please note that failing is better than inconsistency. Let's take one example. Let's say if your bank application is not working, it is far better than something odd is happening. Let's say your balance is getting incorrect, yeah, right, in your application. Then that is worse than your application not working, right? Remember this point. Let's discuss third, which is isolation. Isolation means no dirty reads. That means one transaction is independent of the second transaction. It ensures that concurrent transactions do not interfere with each other. Intermediate states of a transactions are invisible to the others until committed. Let's take one example. Let's say your A is uh, transferring money, right? Uh, and while B user is querying it. So let's say the original balance was 1,000. A is adding 500, right, to this. Then your balance will become 1,500, right? Then if B try to query, right? If B try to query the balance, then if B is trying to query before A, then he will get 100, he will get 1000. If he's querying after A, then he will get 1500. There will not be anything which is happening in between, right? Nothing in between. So B should not see the partial or partially updated balance during A's uncommitted transaction. So B will only see correct balance. If A's transaction is perfectly committed, then he will see 1500, otherwise he will see 1000. Let's take another example of ATM withdrawals. Two ATM withdraws 10,000 at the same time from a 15,000 balance. Isolation ensures only one withdrawal succeed, right? This is another example. Let's say you are trying to withdraw 1000. Another user is also trying to withdraw 1000. The one whose transaction is coming first, right? Whose transaction is coming first will make sure that uh, that transaction is getting committed and second is getting failed. You could be having some questions here that, let's say, if both are coming at same time, then what will happen, right? That's what your database ensures, that only one transaction processes, other does not. The second either waits or fails based on the DB locking or isolation level. See, DB performs locking, and there are some detailed discussion which we can do here. But in the interest of time and just discussing it from the top level, we are just concluding it here. A lot of locks happen in the DB. Sometimes table level lock, sometimes row level lock, right? But only one transaction flows. Now the last part of discussion is durability. Durability means once committed, it always persists, right? That means if a transaction is committed means your transaction is successfully executed, then its changes are permanent, even if the crash happens. Let's take one example. Let's say you updated the balance to 1000, right? Now, if your database crashes, that means your system turned off, or some electricity is going away, right? Then, if the electricity comes back, then also your balance will remain 1000. This is called as durability. It ensures write ahead locks, disk flushes, and replication are handled very well. After a commit, if a power goes down, then when the database restarts, your transaction is still saved. It does not happen that your transaction is invalidated or lost or something happens. It won't happen there, right? So it is, so please note that, which is also mentioned, that write ahead logs, if disk is flushing means cleaning, replication means you are copying A to B, right? Then your uh, system remains consistent, and this is called as durability. Now let's summarize this in detail. What does atomicity means? It means all steps succeed or none succeed. Example was money deducted only if also credited, right? We discussed this example. Money will only be deducted. That means debit will only happen when credit happens. Consistency means DB constraints are always respected. Example was you will never get negative balance. Third step was isolation. Transactions do not interfere with each other. One user change does not affect another user change, right? Or and the fourth one is durability. That means committed data survives crash. Crash won't undo a successful transfer. That means if a transaction is committed, then even after crashes, the transaction remains there. So that's all. I hope you liked the lecture. And if you haven't subscribed to SY Academy, please do. Thank you.